Let's look at this problem. Convert sorted array to binary search tree. Given an integer array nums where the numbers are sorted in ascending order, convert it to a height balanced binary search tree. So in a binary search tree, we know that the elements which are smaller than the root will be on the on the left, and the elements larger than the root would be on the right. We are given a sorted array, something like this, and we need to convert it into a height balanced binary search tree. If we take this example, to convert this into a height balanced binary search tree, can we say, how about we go to the middle of the array and we consider it a root? And then we say that, okay, the left subtree and the right subtree would be these elements. And next, we would choose the next root. So over here in this array, we can choose the next root as either this or this. It does not make a lot of difference if this 10 is over here on the right. It would still remain a height balanced tree. Over here, very similarly, 5 and 9, anyone can be the next root. So if we have another example, if we have something like this, we can consider the middle as this element over here. We have 4 elements here, we have 5 elements over here. If we consider this as a root, we would have equal number of elements on the left and the right, which can be arranged to form a height balanced tree. If we had chosen this as the root of our tree, we would be making something like this, and this would never be a height balanced tree. So if we limit the number of elements to either equal or almost equal, just a difference of 1, we can guarantee that the number of elements over here can also be arranged in a way that is height balanced, which means from this subtree, if we take the middle, let's consider this as middle, this can be arranged as 2, 1, 3, and 4, and this has a maximum difference of 1. That would make it a high balanced tree. Similarly, on the right side, we can take this as the middle. So 8 would be the root. We can have 6 or 7 over here, something like this. We can have 9 over here, we can have 10 over here, and this would be a height balanced tree, which means in any of these arrays, let's take the middle, call it the root, and then call the same function recursively to construct a subtree from here. So choose this as the middle, choose this as the middle. This would be the subtree. So now let's try to write this algorithm in the code. So I am here in the code editor. I have this function sorted array to BST, and it accepts a nums, which is the input array given to us, and we need to return the root of the constructed height balanced binary search tree. The first thing, I would like to create another function because the parameters over here are just nums and I need to divide the array, and for that I'm going to need some extra parameters like left and the right pointer. So let's create another function. Let's call it convert. Self, I need nums as my input to this. I need a left pointer which would point to the left bound of the subarray, and over here I have right which would point to right of the subarray or the array. After that, I want to calculate the middle of this array from which I would divide two arrays which would represent two subtrees. So middle equals to left plus right, integer division by 2, I get a middle. After that, what I can do here is I can divide my array, which means I can say that we are in the middle, the left of the array becomes the left subarray, and vice versa. To convert, nums left would remain the same, and the right would become middle minus 1. Similarly, self dot convert nums comma, in this case the left would become middle plus 1, and right over here. So we have this convert function would return us a root, which means how about when we are on the middle, how about let's create the node which we need to return. So let's call it node, or let's call it root equals to 3 node, and we pass the value as mid, not mid but nums of mid. This would be the value, and this would give us the root of the left subtree, this would give us the root of the right subtree. And we know that in a tree the root points to its subtree, which means root dot left equals to this, root dot right equals to this. We need to point to these subtrees. We also need to take care of the edge case. If the left over here is moving in the right direction, we need to make sure that the left does not cross right. In that case, we are basically done with the division of the array. So we can say if left is less than right, this is something that would happen for the leaf nodes. So we can over here say return none, which means after the leaf we have none in the left and the right part of it. So we can return from here when left becomes larger than right. This should not happen. At the end, we can return the root from here. Let's call this convert function. Let's return the value that we get from the convert function also. So nums, for the initial phase, we would pass 0 and the length of nums and -1. These would be the edge indexes. Let's try to run this code. Let's submit it. So we have it passing.